So remember, why bioinformatics? Your model on bioinformatics, not the guy's model. You're gonna get a library book in 2 weeks' time. In 2 weeks, you're gonna get the book. But the books, it's like weird because you gotta get a bioinformatics books. It's like biological information. It's based on DNA model. It's kind of chemistry. So you have to ensure that the structure of your information is coherent. So you can have like a future photorencek. Think of it like active recovery systems. For polyglot computation, they recover quickly because the structure is coherent enough to receive the information. You don't have to open a channel because the information already is open in there, but the information is there. In informatics, it's a subset or the substrate of that structure. Now, the substrate refers to the structure of the information, but it can be modeled anyhow, whether heterogeneous or homogeneous. But the structure is a subset. Now, because the subset is the structure of the information. The substrate is the thing of information based on cohesion of the union. How much information you have to work together. So what you're going to do, Namdi, is remember to tell yourself that it's not hard because you use your model on bioinformatics. Just use the algorithms and prune out clarity from that book. You don't even have to read it if you don't want to. Skim and scan. Other text is skim and scan. Don't read the whole thing. Those things, those are fine root. So biological information literally means like the all information is all around it. It's just a very noisy system we're in, and we can perceive it with our own senses. So the information doesn't look like anything. You can't make sense of it because there's not enough information. In the same place, look at it. There's enough structure. That's the Python. So basically, anything like Bluetooth will thing, just make sure it makes sense on bioinformatics. But the thing is, you got to remember is just to try to develop Gossilang. Gossilang, that's the world's first polyglot programming language. The Gossip programming language. Try to make that video today. Give it uh, I call it a Gussie manual. So you go to the GS files, which are gossip like files, but the system has to have architecture, infrastructure architecture, and architecture infrastructure in a bi-directional resolution system. And when somebody doesn't resolve, you have to get a Gussie manuscript, which is GSM file. That's a manuscript. It's like someone trying to fix something that's broken using their own interpretation of it. It's like you're the interpreter. The program has to interpret your intent, your statement is we're trying to express the intent layer. It's the thing about the GSM files. They are gossip files, but it's for it's allows you to make it talk to any programming language. But it's more of a. I'm thinking it's very process. I don't want to do it yet because it's very. I'm just talking about it now, but. I have to try to develop something that is good enough to talk to, because I can have basically Gussie language is compiled. It's compiled language. You have to wait for it. Something that was a Gussie long time. We can have a Lua, but I want to. It's just an extension of the Gussie language because it's an interpreter layer. So you can use it. You can use GSM files with Lua, Python. Just naturally with Gussie language. You don't need to compile before you run. That's the compiler runtime dilemma. Because you don't when you run when you're using a runtime, you are already in the environment. You can really start to do whatever you want to do. But we have to recompile everything and reactivate everything. It's just a really annoying two steps process. Compile, build, run. That's a compiler. Run. Just run, just like run the file. The computer understands what you're gonna run. That's what the interpreter is. This is ensure that the system has two models of interpretation, like at least two options to navigate some bureaucracy system. Two options. Give people options. Whether it's a UI layer, the GSM files and the GS files are gossip files. They're files that gossip that took to any program. It's in network languages. Now the manuscript files are the same are isomorphic, but it's just like I just want to make sure that people are using it correctly because it's gonna be like Lua, but it's gonna be focused on polyglot interpreted systems, like things that just run at runtime, runtime layer, like games, or that don't have to rebuild the whole process. And that's the application of just games, real-time systems, safety critical systems. That's why it's very good to have that kind of universal translator adapter bridge for resolving runtime systems. So you don't have to, if you want to use a compile language like C, just pick the right choice. Develop the schema for that. The gossip polyglot program language by me, Namdi Akbala, try to do it well and try to do a YouTube video today and demonstrate Gussie Land. Okay, using bioinformatics too. Informatics subset information or substrate information. All the full informatics is good information. That's what basically you have basically, and data. Data is just one unit of information. So you got the unit of information called data. Now you got the informatics. That's the sum of the information. You can solve the problem or may not solve the problem, depending on how the problem is solved by the algorithm. And then you got the information, the full set of information to solve all the problem, and then allows you to recover everything, fix everything, 4 tolerance modes, 2 notification, 2 programs, 2 interpreters, 2 everything. Just so people can fix their problems. So that's your master. You're building directed symbiotic evolution systems, which you call directed symbiotic DSC. But that's like DSC RAM, DSC key pad, or something based on biology, genotype, phenotype, genotype phenotype duality model. One more thing, the genotype is like a genotoken type, you think of a biological, like adenine, thymine, cytosine, guanine. Genomic, like genome, genetic, a genetic code, genetic token type, genetic value, so genetic token memory, for that thing that's a feature, that's a gene. Try to model like that, and then the phenotype is the feature that gene propagates. I think this is kind of evolved, but I know this is kind of evolved by I haven't got the algorithm yet because I'm outside. I'm still in the library. I don't want to stress myself. Like the phenotype, meaning like the feature. Like I have a hand, fingers. I have fingers, but these fingers are designed in a way. These are my genes. These are my genes that are doing this. But the feature of these fingers are the color, but the colors don't do anything. The colors don't do anything. They could be there for show, for mating, but they don't do anything. They're not an actor in the phenotype world. But the genotype doesn't need to act for the phenotype. Unless something in the genotype breaks, then the phenotype have to change its feature. But that genotype, that's called cancer. Anyway, try to model that with a null, meaning no token or type. Nil, NLI, meaning like a garbage collected nil. NIL, no memory, no token type, no value, and AVIA3 on the notation using red-black elimination. Now, red-black elimination is just algorithm that basically you prune trees. Anything red gets pruned. You gotta remove it. You gotta prune it. You gotta remove it because it's not needed. You're gonna update it. So the system doesn't decohere. So the pruning algorithm is based on red-black elimination. That's your algorithm because if you have a system that's red, it's marked as red. A red node in a tree, a graph. It's pruned out, and the pruning is a process that you keep all the black. So when people use it, they prune out. They keep getting black nodes, and prune out all the red nodes and update it. The system must keep coherence. That's the pruning algorithm. So the pruning algorithm must match the encoding state of the system for coherence operator modeling, such as genotype and phenotype modeling, for that first set feature that can evolve over time. The system must solve this problem and ensure diamond dependency issues, library, all that library stuff. Based on semilantic version X. It's a large project, but I want to finish that semilantic version X so I can build my own registry. That's what I'm saying to you guys. It's not a difficult thing to do. It's just this kind of a barrier for me. So genotype modeling, AVO3, red-black elimination, tree and pruning algorithm, and other things. One more thing. Anything I'm missing? Oh, null to nil elimination. And architecture, schematic architecture. You develop, try to ensure that that genotype model can be used for something. I know it's biology, but I know some. You can try to prove up a schema, look at your code, the structure, apply human. That's called Gaussian because that's the structure of your code. It's like basically it's like you're trying to make a blueprint with a programming language, and the programming language doesn't tell you that this actually looks like this, and you got this structure right, but you're missing this kind of structure, so you're making the wrong structure for this architecture. So basically, the system can build itself and heal itself. Just the hardware. And the hardware is the silicon, the silicon itself. What else, Namdi? Profiler. Okay, try to develop a profiler for the system. Active one, something that's based on you call it a pluffer, but a pluffer is a red-black pruning algorithm that prunes nodes, but it's a profiler. It's an oral. So basically, it's a compression algorithm, but using compression to see less, obviously, because it's meant to see the structure you're envisioning. It doesn't. It's like weird because it's based on consciousness. consciousness is subtractive. It doesn't want to do anything else. So basically, if I let my teaching consciousness, your cognition is what the consciousness was preserved. So you start to see the bigger picture, and the more you try to do your job, the more it clears out past to see the right direction, and it doesn't block out anything because you're conscious about it, you're aware of it. So you are meant to try to develop an algorithm using consciousness model that's subtractive, so you don't use any energy. And when you make a mistake, you see less. Of your mistake, you see less of the you just see the right stuff. You see less of more of your errors and less of your mistake. And if you make a good, you see more of your wins and less of a mistake. So the algorithm compresses everything and then can package it with an oral seal, and that will be the 512 algorithm. And when that's done, you will be set for your PhD, because that's a systematic version extended based on AVR red black elimination for updating packages such as Node semantic version X, Python, Lua, Go semantic version X, or the semantic version X, bidirectional directional acyclic graph precision, and the phenomenological type to genotype model for scalability. Which is very good to scale architecture. It's about ensuring that each feature is defined as it is, and a verb noun concepts to for coherence operators. And there's no point of working on something when you don't have coherent implementation. Understand how systems work innately. You don't fully understand the whole system. Okay,